So I'm going to record one of the questions in inventory management, as I promised that I was going to show how you can work on this kind of question. We have one question in exam, so a number of students have asked me to provide a video to show how did we complete this kind of a question. So the question is posted in the Brightspace, and it says a discount appliance store uses a continuous review system, which is Q system, and one of the company's items has the following characteristics. So I'm going to use Excel to create business model or economic model that will help us to solve these questions, which says what is the EOQ or economic order quantity, what is the desired safety stock, and what is the desired reorder point. So let me bring in Excel, and so the file for me will be inventory management, and so you can see that we have demand, which is regular demand, or we can say average demand, and this one can be presented as D. And let me go to this column and just put 10 items. So that is our regular demand or average demand, which is on weekly basis, so items per week. And then we have 52 weeks per year. So let me write here weeks, and we are assuming that there are 52 weeks per year, and so we can actually find annual demand, which can be denoted as capital D, and this one can be found by putting equal sign, click on 10 times 52. So we have 10 items per week. So for 52 weeks, we are going to have 520 items, and those are per year. Now, after this, after calculating the annual demand, then let's see any other information which is provided. So we have ordering cost or setup cost. So it is ordering cost. So let's just write the setup cost, and this one is 45 per order. 45 per order. So it is dollar per order. $45 per order. And holding cost. The holding cost is $12. So that is $12 per unit per year. And so here we are given lead time. This information is important. Now we know that we need to calculate the reorder point. So lead time, and this is the period between when you order new inventory and the time when you are receiving them. So lead time is 3 weeks, and this is normally constant. So after having lead time, we can find a reorder. We can find a reorder point, and formula for the reorder point is regular or average demand, average weekly demand times the lead time. So just put equal sign, click on the weekly demand, 10 times the lead time. And so we know that the reorder point for now is 30 units. You should have 30 units left when you order, and you can wait for 3 weeks to receive new items. And so that means 10 items per week, 30 units or items for 3 weeks during the lead time. So that's the reorder point. We have to reorder when we have 30 units left or 10 items left. So in this case, then we are given more information. There is standard deviation, and that's the standard deviation during the weekly demand. And so it is 8 units, or we call it items. So here I use the term items, but it can also be units. So those are the fluctuations, the average fluctuations from the average weekly demand. But we need service, cycle service level. So we have cycle service level. So this one is given as 90%, and 90% can also be considered a probability. And it's important. We're going to utilize it to find the z-value, but let me come to that. So all that is the information which we have to have. So now there are a number of things which we need to calculate so that we can find the economic order quantity. And in this case, we need to find the annual ordering cost, or C. And also we need annual holding cost, which is HC. So we have a formula to calculate this. So the formula to calculate annual holding or ordering cost, it is demand. It is the annual demand divided by the quantity times S, or the setup cost. And the annual holding cost has the formula, which is Q divided by 2 times H, which is holding cost. This one here. So, but we don't have Q. We don't have this quantity. It can either be policy or it can be desired quantity, which is economic order quantity. So let's find Q. Now, formula to get Q is the square root of 2 times annual demand times setup cost, and divided by H, divided by the holding cost. So here I'm going to write constant, which will represent this value here. So this will be 2. That will be our cost. Now let me go up here to solve this. One. So put equal sign, click on the annual demand, which is 520, divided by Q. Sorry, we haven't calculated this yet. So to get Q, let's do the calculations. Put equal sign, then just type SQRT, square root, and that will be square root of 2 times annual demand, which is 520, times setup cost, which is 45, and then divide by H, which is holding cost, and close the bracket. So if we can enter, you'll see that we have 62,44,998, and these are units or items. Sometimes we cannot have decimal points for items, or sometimes we may have decimal points. Let's leave this as is for now. So that is the quantity. We have no idea what kind of quantity is this. It can be just the regular policy, or it can be desired quantity. We call optimum quantity, and if this is optimum quantity, then we can call it economic order quantity. Now we have our Q, so we can replace Q for annual ordering cost and annual holding cost. So just put equal sign, click on the annual demand, which is 520, divided by Q, which is this one, and times, so let me close the bracket, and this will be times S, which is setup cost 45, and enter. So we have 374.6999. That's the annual ordering cost. Let's find annual holding cost to see if they are equal, and so if they are equal, then that means that our Q is at optimum. So just put equal sign, click on Q, divided by constant, which is 2, this one here, and I'll close the brackets, and then the formula says times H, which is holding cost. Sorry, let me redo this. So just put equal sign, click on Q, that is, let me close the bracket, divided by Q, times, just put Q, divided by 2, which is constant, and I will close the bracket, and this will be times holding cost, and holding cost is 12, and enter. So you can see we have same, and therefore this is actually our economic order quantity, because it's at equilibrium where OC equals to HC. Now the next thing we can do is to find the total inventory cost when we operate at equilibrium. So just put equal sign, and total inventory cost equals to OC plus HC, or I'm going to put the sum of these two. Close the bracket and enter. So that is the annual inventory cost, or the total inventory cost. So if we can go back to the questions, it says that what is the economic order quantity? Economic order quantity is this one here. That is the economic order quantity. The second question says, what is the desired safety stock, and also what is the desired reorder point? So we need to find the safety stock. So what is the formula for safety stock? Formula for safety stock is Z score times the standard deviation over lead time. So we need to find Z score, and then we need to find the standard deviation over lead time. Z score can be found for those who have taken statistics will understand this, but let me just write it here, but I'll show you also the simple approach. It is the confidence level, or we call probability at the center, if you're considering normal distribution curve. So we have probability at the center plus the area to the left of the distribution. And since we have left tail and right tail, then we will take 100% minus confidence level, and this will be divided by, we can divide by 2, and so we get the z-score, where we have probability at the center plus probability of the left tail. And so in this case, the CL, or confidence level, is actually this cycle service level, which is 90. So let me go down here. It is put equal sign, it is 90% plus 100% minus 90%. I'm just following this formula, divided by 2. And in this case, we have 95%. And all we can do is we will use this 95% to get the z value of the confidence interval, because we are considering two tails. For those who took statistics will understand this. And therefore, in this case, we will just put equal sign and type norms inverse. Please use this function. You can use norm.s.inv, or you can use this function in Excel. So just put equal sign, type NORMS, and it will show you. And so in this case, I am required to just put the probability, and so probability is 95, and if I close the bracket and enter, you will see that the z value will be 1.644854. So I'll show you the very simple approach to this. Now you can see that the cycle service level is 90, and therefore 90 is the probability at the middle, and so we'll take 100% minus this 90, and then we are going to get 10%. This 10% has to be shared for both two tails, and so we divide by 2, and so we're going to have 5% for each section. Now to find the z value of the left side, it will be the probability, which is 5%. Remember, we took 100% minus 90. We get 10%, and that 10% has to be shared for both tails, left tail and right tail. So 10% divided by 2, we have 5%. So that is the probability we're going to use to find the z value. So just put equal sign and type norms, and then you can select the norms inverse. Can you just put 5%? Close the bracket, and so we're going to have z value of the left side. But for now, we need the positive one. So you can see they are almost more or less the same. So we're going to use this positive one without negative. So that's how we can find the z value. Remember, formula for safety stock is z times standard deviation over lead time. So let me go here. Standard deviation over the lead time can be obtained by using this formula. It is the standard deviation, which is given. We have standard deviation here, which is 8 units, times the square root of L, square root of the lead time. So let's do the calculations. So to find the standard deviation over lead time, just put equal sign and click on standard deviation times square root, SQRT, which is square root of lead time. So let's find lead time here. Lead time is 3 weeks. So click on 3, close the bracket, and I think we are set. So it is 13.85641. Now, for those who took statistics, this is what we call standard error. But now, let's find safety stock, which is Z times standard deviation over the lead time. So, safety stock, we're going to consider this formula. So just put equal sign Z, which is this one, times standard deviation over lead time, which is this one here. Standard deviation times square root of L. Click and enter. Now, for those who took statistics, can remember margins of error. And now we need to add this safety stock to the reorder point. So question says, what is the desired safety stock? That's the one we have calculated. What is the desired reorder point? So we knew that reorder point is 30 units without considering safety stock. So we're going to consider safety stock. So reorder point, just put equal sign, click on reorder point, which is 30 plus safety stock, and our safety stock is this amount, and enter. So you can see that here we have 22.79176. So we could approximate this to 23, or we could just leave 22 so that we won't have the decimal points. But anyways, we know that we are just adding 22 or 23 on top of the 30 items so that we will be on the safe side. That's all, and I believe that you can now do your final question. Thank you.